All right, so thank you for coming, everyone. My name is Daniel, and I will be discussing C++ and how this relates to music. So how I got into this, I am originally a singer and music producer, so I've been doing singing for a while, since I was in high school. I recently started doing music producing as well. I really like it. I wanted to kind of branch out as a singer. I wanted to be able to write songs myself as well. And so that's how I kind of got into that world. So I do post stuff on YouTube. I'm a singer. I like to post covers on there. I also put some original songs. And previously, I also was a voice teacher and an SAT teacher. So I have some experience in other things too. So how I kind of got interested in how programming applies to music was when I was doing pitch correction. So nowadays, pitch correction is used pretty ubiquitously in the music industry. And it wasn't always that way. It was something that's pretty recent. Maybe about 20 years ago, it became really popular. And so we're going to talk about that a little bit later, how that kind of works. But first, I kind of want to give you guys an introduction to what C++ is. So is anyone here familiar with C++? Right, cool. C++ is pretty ubiquitous in the industry. It's used for a lot of different everything, pretty much. Like a lot of programs we've written in C++, programming languages we based in C++. For example, we have Adobe. A lot of the products have been written in C++. Maya, which is something that 3D animators and people who do studio graphics use a lot. Even Apple products use C++, Google Chrome, and pretty much games, desktop apps. It can be used for pretty much anything. It's sort of like a Swiss Army knife of programming languages. So what makes it awesome is that it's pretty powerful. It's very fast because it's compiled, it's statically typed, and it's very scalable. What that means is that as a scalable programming language, we can use it for large projects. We also can have a lot of control over the resources that we use. In C++, we have to allocate memory pretty frequently, which means that we have to know what's going on. We have to know what's going on with memory. We have to know a lot about what's going on with the program, and so we have to have a good understanding of how programming languages work. So, yeah. Okay, so is C++ hard to learn? The easy answer is yes, it's very difficult to learn. The reason being is that there's a lot of syntax that is confusing for people. If anyone's familiar with Python, that's very simple. Like, it's pretty much English when written out. But with C++, there's a lot of things that are going on that we don't really think of intuitively. Okay, so there's a lot of things to keep track of. In C++, we have to work with memory allocation. So is anyone familiar with what that means? All right, yeah. So essentially, we have to, when the computer stores some data, there's always some sort of memory allocation going on. So, we have to think about what's going on with that. For example, when we have, an easy way to think of this is when we have a variable and we want to kind of keep track of that, the easiest way to think of it, we have to store it in some memory address. So what that means is a lot of programming languages will do that for you. You don't necessarily have to do it yourself. But in C++, a lot of times we do have to be careful with how we allocate the memory. So another thing that's related to that is pointers. So pointers are things that may be variables you can think of that point to certain addresses in the memory. This is how we can access certain objects in the memory, and that is essential to understanding C++. There's also consistent typing, which means that if you declare a variable as an integer or a string, you have to keep using it as that. In things like Python or JavaScript, you can reassign things pretty easily. That's not the case in C++. There's also data structures. So in JavaScript, we have something like the JavaScript object, which is underneath it. It's implemented as a hash map. So it's pretty easy. It's really easy to use, but in C++, you have to kind of understand how to make a hash map yourself and how they work. Okay, so what does this have to do with music? So with C++, because it's a powerful language, it is used in a lot of different fields to do things that are resource heavy. When it comes to music, especially as like a pitch correction app, you would need to make sure that whatever you're doing is done quickly and resourcefully. All right. It's also fun because when you think of these topics, the music industry is kind of mystical to a lot of people. They don't really understand how it works. Things like pitch correction is something that a lot of people just kind of know as like Autotune. And Autotune in and of itself is very complicated, but a lot of people don't really understand how it works. Okay, so I wanted to kind of cover like what a basic program would look like in C++. So in C++, we have to have our main function. This is necessary for writing the program generally. So what that looks like is we usually set it as an integer, and we return 0. So why we do that is because that allows us to tell the program when it hasn't run successfully. If it returns 0, we know that the program has been executed successfully. Otherwise, it can mean an error. It really depends. This is just a general overview of that. And the program will always execute from main. So when you write your program, you have to make sure that you write what you need in main. Okay, so a pointer, as I mentioned earlier, is a variable that points to a variable's memory address to be like a lot of different things. So in this example, I have an integer foo that is set to 5, equal to 5. I have this pointer. So the pointer is it's referenced using the asterisk here. So when I output that, we get 5. Foo is 5. When I output the memory address, so the asterisk here, it's something that dereferences an address. What that means is that we are going to get whatever is stored at that address. So I output that, and it gives us 5 as well. Okay, so let's see who's been paying attention. What will the first thing here output number? Anyone have any ideas? Yeah, awesome. How about the second one? This one's a little bit tricky. You don't have to know the exact thing. Just yeah. And the last one? Yeah, awesome job. Okay, so memory allocation in C++, it kind of looks like this. Like when we have an array, this is like a standard C array. We have 5 blocks of memory here, and each of these things are being allocated to that block of memory. So the array size here is static. What that means is that if we set it as 5, it has to be 5. We cannot, like in JavaScript we have push, you can't do that. Like a list in Python, you can append, you can't do that here. What you can do, though, is resize the array. So let's say that we wanted to make an array of size 10. I have an example here. It's a little bit complicated for the sake of demonstrating it, but essentially what I'm doing here is I'm like, okay, I'm going to resize the array. I'm going to say it has 10. The next things are copying the first 5 elements of this array into the second one. So I copy the first 5 elements, and then I add what I want into the last 5. So that's some way you could resize the array. And I wanted to cover one more thing that was really helpful as someone who is experienced with JavaScript. I came across this thing called an unordered map in C++. It's pretty similar. You have to import it, sort of. And internally, it's implemented as a hash table. It's helpful for JS developers when they're learning C++. So if you are really familiar with JavaScript and you wanted to do C++, you could try doing this. There's a few caveats, though. You have to use a pointer sometimes, which is very complicated if you're new to the language. So a simple implementation could be like you have your name, and then you have someone's phone number. Alright, so here, for example, I have an unordered map. I'm going to say the unordered map here, it has a key value of an integer, and the value here is going to be an integer as well. So we have to denote whether or not it's going to be an integer, a string, etc. The second one here has a key of an integer and a string for the value. And the last one has a string and a string. So does anyone have any ideas what we would... Does anyone know what the this would output? Foo 0, anyone? 1. Good job. How about bar 1? Hello. Yeah, and the last one? Yeah, awesome. Okay. Okay, so now we're going to move on to some of the more difficult stuff. Okay, so I'm going to talk a little bit about pitch correction again. So why this is used is it's an industry standard. It allows for higher quality songs. We also want to have more efficiency. So as a singer, if you're in the studio and you don't hit the note right, you might have to keep doing it over and over and over again. That would really tire you out. And also, when you're trying to sell stuff to make money, you can't be in the studio all day singing some note over and over again because you don't like how it sounds. So pitch correction really helps streamline the process for a lot of singers. And it sounds great. I know people don't like it sometimes, but if it's done correctly, as in not overly auto-tuned, it can really make you sound a lot better. And also add some complexity to a song. We can do a lot of things by pitch correcting. We can create harmonies. We can do. We can also create a duet, and it also helps blend the sound. So when you're creating a song in a digital audio workstation, we want to make sure that we are blending everything together. And when we're able to correct the pitch, it can really help us blend with the instrumental in the background. Okay, so I want to kind of help people understand the theory behind this. So, we have something called pitch. That's the frequency, and that's measured in hertz. So, for example, on the next slide, I'll show you an example of this. So on the key, it determines which notes a singer is allowed to hit. So for example, if we have a song in C major, we can only hit C, D, E, F, G, A, B, C. So what that means for pitch correction is we know what frequencies the singer can hit. That helps us kind of push the note to the correct pitch. And lastly, people tend to think of scientific pitch notation to help them with things with abstracting frequencies into octaves. So some example of this is we have our frequency, that's 440 hertz, and that's A4, so that means A in the fourth octave. And A3 would be half of that, and A5 is twice that. And that just shows on the going up. Okay, and some history of Autotune. Autotune was actually invented by Dr. Andy Hildebrand. He was an oil industry researcher. So originally, the algorithm behind it was used to help oil companies find subsurface maps to find potential drill sites. So and funnily enough, in 1996, he used it to pitch correct music, which actually ended up being a bigger deal for people. It was a lot more influential, which is kind of interesting when you think about it. And Cher famously used it in her song Believe. Does anyone know that song? Yeah, don't age yourself. Nowadays, it's used ubiquitously in the music industry. And by Autotune, so I just want to correct something about Autotune. Autotune itself isn't usually used by professional producers. It's very robotic sound. So the way they will use pitch correction, I use a software called Melodyne by Solomoni. It gives you the an interface, and you can change each note at a very, very minor level, so you can barely even tell that you're correcting it. And so you listen to it. That's pretty cool. I recommend. Okay, so how do we detect pitch? So for a fast transform, does anyone know what this is? Yeah, a lot of people say they do, and it's a lot of it's a lot. But I'll try to kind of get a little basic here. So essentially, it's with the Fourier fast transform, we want to take a smoothie and we want to get the ingredients. So we're taking say for example, you have a smoothie and you want to find out what each ingredient is. That's essentially what it's doing, except it's very complicated, but more complicated than that. So for example, we have a filter for bananas. We'll see, okay, the banana is 1 ounce. We have a filter for milk. We'll see that's 3 ounces, and so on. Okay, so some of the signal processing basics. So a digital music signal changes value over time. That is stored like a sequence of numbers. Is anyone kind of familiar with this at all? Okay. The larger the number means it has a greater amplitude. So if you see here, it's bigger, that means it's louder. As if anyone's familiar with the waves on SoundCloud or something, you can see when it's bigger or not. The sequence is periodic if it repeats. The length of this section is called a period. And the frequency is measured as 1 over period. That's in hertz. This is what means cycles per second, if that's easier to think about. And high frequency means a high pitch. A low frequency means a low pitch. Okay, so if you wanted to look at it as a graph, this is just a regular like wave here. We can see that it has a frequency of 1. So if you see like this is plotted against time, we can get the frequency very easily. So it really helps us distill things into very small amounts that we can kind of break down. Here, this looks complicated, but when we break it down, we can see that the two frequencies here are right here. We can see the magnitude of each frequency. And here, this looks simple, but actually it's more complicated. So you can see how it can be useful for very complex waves. Okay, so does anyone have any questions so far? No? No. Okay. All right, so pitch detection. So there's two parts when you're creating some sort of pitch correction software. The first thing you want to be able to do is detect the pitch. That's very important, obviously. So what they use is something called a short time Fourier transform. 1 hertz is played for 1 second, and then, so in this example, we want to say that if 1 hertz is played for 1 second and 10 hertz is played for 5 seconds. So normally, we would only know that in the span of 6 seconds, we had 1 hertz and 10 hertz. We wouldn't know in which part they were played. What this will do is it breaks things into 6 windows for each second. So let's say we want to know, okay, first second, 1 hertz played, the last 5 seconds, 10 hertz played. So that's very helpful. And it's usually represented by a spectrogram. Some examples here. Okay, and this is Melodyne, by the way. So it's the pitch correction app I was mentioning earlier. So with pitch correction, we can find the pitch using the previous method first. After that, the singer will sing the fundamental frequency. So anyone know what fundamental frequency is? All right, yeah. It's when you sing a note, or when a note, any kind of note is played, there's many like harmonics, so like, a lot of different frequencies being played at the same time. The fundamental frequency is what sound is heard. So when I first learned that, it was kind of mind-blowing. Like to know when you first go over, when I first learned singing, you kind of know, okay, I have to hit the right note. I like have to sing the right pitch and like, that's it. Actually, when I found out that there's multiple frequencies always being heard, you just like, and it actually affects the sound, I was pretty mind blown by that. So yeah, you detect the fundamental frequency, and then a sound from a singer is often filled with random noise too, so you kind of have to account for that. So how the pitch correction works itself is it's through time scale modification. That means that they will like double the frequency and then halve the period by doing so. But when the period is halved, the signal loses like half of the time. So it's like you have to really accommodate for that. And yeah, so I wanted to mention one more thing about pitch correction. So there is in Melodyne, there's something also called the phase shift. So one thing that happens when you have like a note that is you sing into a microphone, for example, it will have vibrato, if anyone is familiar with that. So you can be singing and it'll be like vibrating, if anyone's familiar with that in a singer's voice. So how we can kind of accommodate that is in Melodyne, it will even detect the minor changes in the frequency there. And then you can either just like stress that out, so you can make your vibrato sound longer or make it shorter. So one of the things that I found very fascinating when I was using this was being able to understand how to shift that. And it's actually pretty amazing what you can do. You can make yourself sound like, if you don't even like vibrato, you can make it longer, or you can make it shorter. And it's, in some ways, some people have a lot to say about that. Like, some people think, oh, like, you know, you shouldn't be allowed to alter someone's voice in such a way. But I think nowadays people are coming to accept pitch correction as an essential part of the industry. And so as time goes on, we will even see people are trying to artificially create voice. So if you've seen, like, anyone know Hatsune, what's the Vocaloid. I'm really curious to see how this will change in the future, if people will be able to augment or just completely create voice from software. And so that's pretty much what I have to have for you guys today. If you have any questions, just come ask me. Yeah. Thank you.